Hello everyone. In this video, I'm going to talk about TF IDF vectorization, where TF is a term frequency and inverse document frequency vectorization. We will understand how TF IDF will help us to convert any text into a vector. Term frequency, inverse document frequency. So simply nothing but a TF IDF. All right. So this is again a part of a word embedding only. In the previous session, earlier session, we have seen a count vectorizer. And in this session, we'll see how TF IDF vectorizer works, and we'll understand how the vectorization will happen and what type of the data will be able to convert, right, using this particular technique, right? So as I mentioned, TF IDF is a short form for term frequency and inverse document frequency, right? How it is going to vectorize? It is going to use some kind of a formula here. The term frequency is basically number of times a word appears in the document divided by total number of words in the document, right? Let's understand this guy first. Say that I have a data, suppose say, let's take an example. This is the statement I have. So I will call it as a document, say dog, this one. Number of times a word appears in the document, right? Suppose I'm going to take a it, right? It is a word, and how many times it appears in this particular document, right? So let me see, it is appearing only one time, right? Divided by total number of words in the document. So how many words we have in this particular document? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So assume that there are 30. So 1 divided by 30 is the term frequency for it, right? So whatever the data you get, 1 by 30, so that is going to be whatever the fraction you get, 0.0, whatever it is, right? Maybe 3 or something like that, right? So that is basically the vector for it. And the next one is again appearing how many times? Suppose it is appearing 3 times out of 30 words, then that is going to be your point maybe 10, whatever it is, right? So that is going to be vector for is. Similarly, the, how many times the appearing? So suppose say 5 times, and out of how many words? 30 words. So that is basically your vector for this particular word the. So that is simply nothing but term frequency. And how about inverse document frequency? Inverse document frequency, let me take this guys out. Okay, now inverse document frequency says that number of documents divided by number of documents the word appears in. Suppose say that this is one document. Let me call it as 1, and this is another document. Let me call it as number 2, and this is another document. This is the document number 3. Okay, we have total 3 documents. So number of documents 3, right? And number of documents the word appears in. Suppose say that Wikipedia. This is the first word. In how many documents this Wikipedia comes in, right? So first of all, it is appearing in one of the document here. Then I'm going to check this Wikipedia in this document also, right? And I'm also going to check in this document also. Suppose say it is appearing in only one document, then it is going to be 3 by 1. So that Wikipedia is basically 3 by 1. So whatever the data you get, right? So that is basically vector for Wikipedia. And the next time, so 3 I'm going to get, and one more thing I forgot to mention, I'm going to apply a log on it. Log of 3. That is basically wiki vector, right? So wiki vector. So next time, what I'm going to do, let me remove this. So okay, so definition. So for the definition, so how many times definition appearing, right? So I mean to say that out of, say that 3 documents, first of all 3 documents, it's not going to change, divided by in how many documents this definition word occurs. It doesn't matter if definition is occurring 20 times in the same document, we are not going to consider that, but we are going to consider in how many documents definition is occurring. So it is occurring in the first document, and I will check in this document, I will check in this document, assuming that if this particular word is appearing in the 2 documents out of 3, then the 3 divided by 2, then the log to the base 2, right? So that is going to be the vector for definition. Log base 2 divided by 2, whatever the data you will get, that is basically a definition vector. So that is what the inverse document frequency formula says, right? Once I get that, so what I'm going to do, I will have a term frequency TF multiply by IDF. I know how to get a TF. This is the formula. And IDF, this is the formula. I will get one data from here, one data from here. Simply I'm going to multiply it, right, for each and every word. So that data is that number or the vector what you get is basically corresponds to that particular word. So same thing will be applied for each and every word in your documents, right? You may have hundreds of documents, right? You may have a lakhs and millions of words, doesn't matter. If I use this formula TF IDF, it is going to convert, it is going to vectorize for each and every word in the documents, no matter how many documents you have. All right. So what we'll do, we'll try to use some example and execute and see. So before that, let me show you this example so that you can understand in better way. So let's say document 1. So this is document 1. So frequency I'm going to check. So how many times this is an example appears? This appears only one time, is one time, and one time, example one time, right? One time, one time, one time, and one time. And how many words we have? Total 4 words. Now I'm going to calculate the term frequency. Term frequency is frequency. How many times a particular word is appearing? One time, one for THIS, divided by total words. How many words? 4 words. 1 by 4 is 0.25. Similarly, 1 by 4, 0.25, 0.25, and 0.25. This is basically term frequency. For the IDF, number of documents, how many documents I have? 1, 2, 3, right? IDF, 3 documents, divided by number of documents the word appears in. So how many times, in how many documents THIS appearing? Appearing in one document and only one document, 3 by 1. Then I will convert into, apply log transformation. So whatever the data, so this is the data I'm going to get, right? Same thing for this particular word, this word, so I will get everything. Same thing I will do it for a document 2 and document 3. Same procedure, nothing is going to change. First check total words for each and every document, and check how many times it is appearing and in how many documents. So according to this formula, I will keep calculating the data. All right. Now, after that, let me go a little down. So now we know we got a TF and we got a IDF also. So what is the next step? Simply I'm going to multiply TF IDF. So for a THIS, this is going to be the vector. For is, this is going to be the vector, vector for these words. Similarly, we will have this vector, and things like that, right? So this way I am able to now generate vector for each and every word in any of the documents. All right. So that's basically the idea behind this TF IDF. Let's do some practical implementation. So what I'm going to do, I am going to import TF IDF Vectorizer. Just like a count vectorizer, I'm going to import a TF IDF Vectorizer from the same guy. sklearn.feature underscore extraction dot text, then pandas. Now I'm going to instantiate TF IDF Vectorizer, right? And this is basically the data. This is an example, one document, second document until this comma, and a third document. Smooth IDF parameter is basically to add a, the number if there is a something comes up like after multiplying and things like that. If we end up getting a zeros, we'll make sure that we add a 1 there, right? So that is, but most of the time we don't get into it because our words are going to be huge and number of every time documents are going to be different. So just safer side, all right? Otherwise you can skip this also. Fine, TF IDF, and this is the document. Now I will use a TF IDF, this guy, and I will say fit underscore transform, and I will pass this document, right? So then finally, this is the object after a fit transform. I will use this doc underscore vector and column names. So column names, you can just get underscore feature underscore names. That will get the column names, right? I'm going to use the TF IDF, which is already instantiated. And I will say this is the common method that we use to extract the features. So data I have and the column names I have. I'm just going to convert that into data frame. Then I'm printing here, right? Let me execute. So you can see this, all this data. All these are features and respective vectors here. So this is a zero, first document, second document, and third document. We have 3 documents, and wherever the word is present, accordingly, the vectorization happens, right? So that is a TF IDF, and now I'm going to use the same function which we have seen in the earlier video when we are understanding count vectorizer. So I have this same function here, text underscore matrix, and I have argument 1, argument 2. This is again a model I'm going to pass, will be passed here, and I will say fit underscore transform. And also I'm going to pass a message in this argument, which will be called. So the object will be created, the data, basically terms doc, and I will use that doc, terms doc, and column names, and we know that how to extract the column names. This count vectorizer is basically the one I'm passing, right? After fit transformer, right? So the feature names I will be able to extract, right? Just like same in the count vectorizer. So finally, I will convert into data frame and I will return it so that I can print and see, right? Let's see how it will work. I'm going to define the function first. Yes, the function is defined. Then this is basically my message. So 3 documents I have, and I'm just giving a message, some name, and I'm going to instantiate TF IDF Vectorizer, and I'm going to call the function and pass the message for this guy and pass the TF. TF is nothing but TF IDF Vectorizer to this argument. Now I'm going to execute. So you can see that how vectorization happens here. All right. So COVID is appearing 2 times here in the first document. Accordingly, the COVID point is going to be changes, right? The vectors are going to be changed depending upon the frequency and things like that. Because it is appearing more number of times in this document, at the same time, it is appearing in all the documents. That's why you see the vector is represented as compared to other vectors, it is a little high, except this nothing. Right? It depends upon the documents and the number of times it is appearing. So everything matters. So we know the formula, it is going to execute accordingly. Same thing, I have one more message. What is that? COVID is bad, something like that. I'm going to this time call this text matrix using this July message. Now execute. So you see that bad is given a more vector. I mean the data for bad is very high here because of its occurrence, because of its frequency and things like that. All right. So it uses the same formula what we have discussed. All right. So within that we have a n-gram also. So I'm going to use a count vectorizer and TF IDF vectorizer. So I have some data here. Car was cleaned by Jack. Jack was cleaned by car. 2 documents. Now I'm going to use a count vectorizer. And here I mention a n-gram, 2,2 by gram. And I will say vectorizer dot fit underscore transform. And finally, I will get the feature names and I will convert that data into an array. And this is how it will produce. Right. So by car, how many times is by car? Suppose say this is the first document. Okay. So in the first document, do we have a, let me, okay, give me a second. I will just show that. Okay. I think this is fine. So what it does, it will check is by car appears in the first document, in this document. Do we have a by car? No, we don't have a by car. Right? So do this thing by Jack is there, nothing is there. This is with respect to first document. Do we have a by Jack? Yes, we have a by Jack. So yes, it is appearing one time. Do we have a car was? Yes, car was is present. Right? And do we have a clean by? Yes, clean by is there. Cleaned by. Yes. Then do we have a Jack was? No, we don't have a Jack was. Then it's a 0. Same thing will be checked for the second document. Accordingly, 1010 will be present, placed over here. Right? So that is basically how n-gram count vectorizer works. This is how the vectorization works. Now let's understand, I'm going to use the same thing. This time I'm going to use a TF IDF vectorizer. Everything is same. Only TF IDF vectorizer I am going to use. And here again I use the n-gram range. Then I execute. You see that how the vectorization happens here. Right? It is going to happen in different way, as you can see here. Right? So based on the formula what we discussed. Right? Same thing. This time a normalization I'm saying a none. So otherwise everything is same. So this time basically the vectors are going to be different. Right? So normalization is basically getting a data, taking average and things like that. All right. So those things we'll be discussing in the upcoming videos. Yes, that's all in this video, and we'll see you all in the next video. Thanks for watching and keep learning. Thank you.